watch this presentation. My name is Jonathan McDonald. I'm going to spend the next 40-ish minutes or so talking about ensuring business continuity with Tableau deployed on AWS. I guess I should first start by talking about what I mean by business continuity. So I grabbed this definition from Wikipedia. Business continuity planning is the process of creating systems of prevention and recovery to deal with potential threats to a company. So what we're really talking about here is a scenario where you've deployed your Tableau server platform on Amazon Web Services, and you want to make sure that this is resilient as possible, as fault tolerant as possible, and as secure as possible, and build in safeguards to help you recover quickly. So that's what I mean by business continuity. And I'm going to run through some kind of tips and advice on how to get the most out of AWS and the various services that they offer and how to help you do that. But first, I'll talk a little bit about me. So I am responsible for AWS and sort of general infrastructure solutions at the Information Lab. I've been a Tableau user since 2011, and I've been a consultant at the Information Lab since 2014. I am Tableau server certified as well as AWS certified, and I like memes, and you might see that come across in some of the slides this afternoon. If you don't know about the Information Lab, we're an analytics consultancy. We're headquartered in the UK, but we do have offices in several European countries. We are the largest Tableau and Alteryx partner reseller globally. We're also an AWS Select consulting partner. We partnered with AWS a couple of years ago now. And really our focus is on enablement consulting. At least that's what I like to call it. You know, Tableau and AWS for that matter are self-service tools. And so what we like to do is to provide consultancy and training to organizations to help enable them to use these tools rather than coming in and just doing it all for you. So that's what we're all about. In terms of the agenda this afternoon, we're going to talk through a couple of themes. I wanted to give you some advice in these various different areas around how best to set up your Tableau server on AWS. And when we talk about that, we're talking about how to spec your servers, how to secure the environment, how to make sure you're doing backups properly, how to configure alerting, what alerts to configure. There are some considerations around availability and fault tolerance as well. And lastly, I'll finish on the server management add-on, which is a product, relatively new product offered by Tableau, and bringing all of these things together with a sort of DevOps approach. I have included a bunch of links to various different resources in my slides. We're going to be sharing these links in the chat window, so do keep an eye on the chat, and you can find the links in there. This session is also being recorded, so we'll probably put it on our Information Lab YouTube channel. You'll probably see it pop up there a day or two from now. But feel free to ask questions as we go along. Just pop the questions in the chat. We're going to leave the answers for a Q&A session at the end, but you're welcome to just throw questions on the chat in the meantime. Great, so let's get started. First, I just wanted to talk a little bit about something that the Information Lab has started offering relatively recently, I'd say in the last year or two. And that's a managed hosting. So, you know, if your organization is looking to deploy a Tableau server, or you have an existing Tableau server deployment that you're looking to migrate to the cloud, and you want to take a sort of more of a hands-off approach, then we do offer sort of managed hosting of Tableau Server on AWS. So you're kind of getting the best of both worlds there, in that we are experts in Tableau Server, but we're also looking after the infrastructure on AWS for you as well. So it's quite a unique offering. If it's something that you think your organization might be interested in, then we can definitely chat about that some more. Along with that, we offer proof of concept trials. So AWS, we've partnered with them to offer funding for running infrastructure for a short period of time, sort of 2 to 4 weeks, where you can actually trial Tableau Server on AWS. And if that's of interest, let me know. And lastly, Tableau and AWS have quite a tight relationship, and they have come up with some incentives if you are looking to migrate your Tableau workload to AWS. It's a reasonably healthy discount on your first year's running costs in AWS if you are looking to migrate Tableau along with any other database or analytics workloads to AWS. And just feel free to pop me an email if you're interested in any of those, if you wanted to talk about those further. So let's get started. I wondered where to start, and I guess the simplest bit is to talk about how to spec out your servers. So Tableau Server doesn't need a server designed by NASA and Jesus to run properly, but you still need to have a decent spec to run Tableau Server properly in production. The minimum recommended, according to Tableau's docs, and also what I've seen in the wild, is 16 virtual cores on AWS. That roughly equates to 8 real physical cores, and is also recognized by Tableau licensing as 8 physical cores, and 64 gigs of RAM. And that's the recommendation for production environment. If you have a look at all of the different EC2 instance types, tend to find that the M5 or the M5A series, the 4x large of those, work pretty well, kind of meet this requirement. The M5A, the only difference there is it's an AMD processor instead of an Intel processor, so it's a little bit cheaper to run the M5A series. Aside from the instance type, this is quite an important point to consider when deploying Tableau Server, is that because Tableau Server consists of a number of different components, and quite a few of those components are databases or Redis cache servers or Elasticsearch, they all do quite a lot of read and write. So you want to make sure that you're provisioning a disk with decent level of IOPS. Now, from various testing and reading the community forums and so on, I've found that it's a good idea to over provision a GP2 disk, and that gives you the best balance of IOPS to cost. So you should aim for a minimum of 1500 baseline IOPS. GP2 disks give you a baseline of 3 IOPS per gigabyte. So if you do the maths there, you end up with a 500 gig disk, which will give you a baseline of 1500. Now, you may not need all of the 500 gigs, but that provides you with the most cost-effective solution. Obviously, outside of GP2 disks, there are provisioned IOPS disks where you can sort of manually specify the number of IOPS you need. But I've found that those disks are a lot more expensive in terms of the balance of the size of storage you're getting to the cost. So just over provision on GP2 is probably the right way to go. And then lastly, the operating system. So Tableau Server supports Windows as well as Linux. In the cloud, Windows operating system has to be licensed. So you tend to find that, especially on AWS, the cost is nearly double of what it is to run Linux server. The obvious caveat with Linux is you do need to have some Linux capability in-house, some skill set. And there's a couple of limitations around supported data sources. So for example, the Linux operating system, Tableau Server on Linux, I should say, doesn't support Microsoft Access, simply because there is no driver for MS Access on Linux. In terms of the Linux operating systems that are supported, Tableau supports several Linux distros. Ubuntu and the Red Hat family were the first ones that they supported. I tend to find deploying an Ubuntu image on EC2 is quite easy. You just click and go. CentOS is another option. You do need to subscribe to the CentOS image in the AWS marketplace first before you can deploy that image correctly. And then there's various support for a couple of other distros, but we tend to find that Ubuntu and CentOS are the main or the most popular choices for customers deploying on Linux and AWS. So to prevent cats on the internet compromising your Tableau platform, I wanted to spend a little bit of time talking about security. And one of the best tools that you can use in AWS, I believe, is the AWS Secrets Manager. And especially if you are using an infrastructure as code approach to deploying your Tableau server, which I would recommend, and we're going to talk about that later on in the presentation, you can use your Cloudformation or Terraform to call secrets via the Secrets Manager API and bring those into your deployment scripts. And I would highly recommend you do that. What it does is obscures the actual passwords and credentials that you're using and keeps them out of any log files or outputs in the terminal or anything like that. So just a really, really handy service to use to lock down your credentials more. In terms of the architecture, I would always recommend deploying Tableau Server in a private subnet on AWS and configuring an application load balancer in a public subnet. This just makes sure that the Tableau server isn't directly accessible on the internet, and there's no chance of it ever being because it's in a private subnet. And the application load balancer handles all the incoming requests. Application load balancers on AWS already have AWS Shield configured on them, so they have some capability to withstand denial of service attacks and so on. But you can additionally configure AWS web application firewalls or WAF against an application load balancer. And with WAF, you're able to configure a bunch of rules which will prevent any malicious traffic being passed through to the Tableau server. Now, you have to define all of those rules yourself, which can be a little bit tricky if you're just starting out with this. So what I've found is a handy script called WAF Security Automations. It's something that was created by AWS themselves. It's a Cloudformation template that you run, and it configures a bunch of default rules for a standard kind of web server application that will limit traffic from certain known malicious IP addresses. It will deny requests coming in from the same IP address if they are more frequent than sort of 10 or 15 hits per second, and kind of just generally block all of that kind of potentially bad traffic. And again, this is really only for Tableau servers that are public facing, that are on the internet. You might not find that this is something you need if you're just running your Tableau server inside your internal network or in a private subnet only. Also, a handy thing I find with the application load balancer is that you can configure SSL on that, and you can configure it to automatically renew your SSL certificate. So it takes away the hassle of having to remember to update the certificate directly on the server machine, at expiry every year or however long the expiry lasts. Last step on security is just to review the Tableau server security hardening checklist. And that's a handy doc that Tableau put together, which goes through 10 or 12 steps. It might be more now They keep adding to it. Things to think about when you want to harden your Tableau server. There's a couple of really obvious ones there, like keeping your server up to date with on the latest version. But there's also some lesser known ones, maybe turning on or off certain features or reducing session timeouts and things like that. It's definitely worth a read, even if you don't feel the need to do that much hardening. There's some interesting tips in there. So winter is coming, as we all know from Game of Thrones, but so is data loss. And that's why it's extremely important to get your backup process up and working properly. I have real life experience of working with some clients that never got backups configured on their Tableau servers and did suffer as a result. So I can't stress this slide more. It's so important to get this right the first time. And the way to do it is to create a backup script and schedule it on your server or schedule it in your enterprise job running application. You also need to have a script which rotates the Tableau server logs regularly. That is important. Tableau server does not clean out its logs automatically. If you just let your Tableau server run indefinitely, eventually it would take up all the logs would take up all the room on your disk, and your server would fall over. So it's super important to A, back your server up regularly, and B, clean out your logs regularly. There's a link I provided here. It's in the chat already, which goes to my GitHub page, where you can download some scripts that I've made, which you can just drop onto your server, schedule it in Task Scheduler or in cron, and that'll get you going. In addition to that, you want to make sure that you're grabbing those backups and your log archives. If you do choose to archive the logs before deleting them, you want to make sure that those files are backed up to an S3 bucket or somewhere off of the server. And there is a sample script in the repo I've linked to, which will help you do that. Now in S3, there's a handy feature called lifecycle management, where you can set the S3 bucket to expire files that are older than N number of days, which I would recommend because Tableau server backups, as you might know, can grow to be quite large. And you don't want to have just tons and tons of backup files going back years stuck in S3 languishing. An important point here, and it's something that I come across a lot, I get a lot of questions about, is, well, do we have to do backups using a script, using calling TSM at the command line? Why don't we just do VM snapshotting and be done with it? Well, snapshots are not backups. And that's particularly relevant with Tableau server. If you think about the components of the Tableau server, there are a database, Postgres database running on there. There's various other database type services running. In order to create a valid snapshot, you really have to shut down the machine to make sure that the file system had integrity. In addition to that, restoring a VM snapshot of a Tableau server to a new EC2 instance will break the Tableau server licensing process and will be considered as an additional activation of your license key. And I've seen it happen that some customers of ours have triggered the key to max out, and then they have to have a bit of an embarrassing conversation with Tableau to free that up. So I wouldn't necessarily rely on AWS snapshotting for your backups. Definitely follow the supported process and backup, create a TS back file using the backup script and save those to S3. That's what's going to help you recover from any kind of disaster. And in terms of recovery, there's a few different options here on AWS. my recommendation is, to script your infrastructure as code, either using Cloudformation, so the AWS native infrastructure as code option, or something else. It might be Terraform, for example. And if you do have that template ready to go, then it's very easy to just run that script again. You can configure that template to restore your latest backup from S3, so that can get you back up and running. And that's one of the options. Another option might be to have a hot or cold standby single node or cluster that you can just spin up in case you need a quicker recovery time. And lastly, something to consider here is whether you have that hot or cold standby in a different availability zone on AWS, or even a different region, in case an entire AWS region goes down. Unlikely, but possible. You can have that recovery infrastructure somewhere else ready to go. I think that always comes down to a cost versus recovery time debate, and you will need to kind of agree and decide on what is the best balance between those two for your business. So alerting, these alerts are equally important for monitoring your server performance and uptime. Tableau server, you can configure event notifications within the application itself. You do need to configure Tableau server to send emails via an SMTP relay. For that, if you're sticking entirely with AWS infrastructure, you can use AWS simple email service to set up that SMTP relay, and it's quite easy to set up. Gives you a bunch of credentials, and you can just pop that into your Tableau server config. Once you've done that, you can then configure some server health monitoring, where you'll get an alert if a process goes up or down, or an entire node in your cluster goes up or down. So this is really useful for running Tableaus. When you're running Tableau server in a cluster, it will still alert you if the node is struggling. Not so useful if you're running Tableau server as a single node, because if the single node goes down, then there is no way for the server to send you an email. The other warnings that you can configure are around drive space. So you get an alert, and this is configurable. You can put in the thresholds yourself to get an alert when your drive space goes beyond 60 or 70%, and then another warning when it goes beyond 90%. You can choose when to get alerted about that. But back to my point about logs growing, if you just let your logs grow and grow, you're going to get that warning. So it's really important to keep on top of your disk space. Outside of configuring alerts on the Tableau server itself, there is Amazon CloudWatch, which is the service in AWS where you can, which allows you to kind of monitor your EC2 servers and configure alarms on various different metrics. For Tableau server, I would certainly consider configuring alarms on CPU consumption. Now, Tableau server does have a tendency to spike on CPU from time to time. So you need to be careful about how you configure the alarm. For CPU, I would maybe look at getting a warning if it goes beyond 90 to 95% for a prolonged period of time. So Tableau server spiking to 95 or even 100%, it's fairly common when it's backing up or when there's a kind of very intense period of user activity. But what isn't common is if that continues on for a long time. Separately, if you're configuring alert on memory consumption, Tableau server likes to gobble up as much memory as it can and just hold that memory for as long as it possibly can. So it's quite common to see Tableau Server just gobbling up 70–80% of RAM. What's not common is for it to grab 99% of RAM. So conversely to CPU, I would say you can configure alert on memory on the amount of RAM that the server is consuming for any amount of time. Disk reads and writes as well. You wanted to keep on top of those, make sure that there isn't a crazy amount of I/O happening on the disk. And load balancer traffic just allow you to keep on top of any attacks against your load balancer. If you're experiencing a large number of hits or requests coming through to the load balancer, then you'll definitely want to know about that. CloudWatch also allows you to install an agent on the EC2 boxes as well. And that agent can collect logs from a number of different locations on the file system. You basically configure it yourself to pick up logs and then send them to CloudWatch. And that can be really handy if you are keen on understanding more about your Tableau server deployment. It can grab logs from the Tableau server logs directory and pipe those into CloudWatch, and then you can do all sorts with them. You can pass that out, chucks it all into an S3 bucket, and then and use AWS Athena or any other kind of tool to analyze that a bit more deeply. Okay. So in terms of availability, no one wants a Tableau server that works 60% of the time, which is why you should really consider deploying a cluster if availability is a priority for your business. And on AWS, I found out something interesting the other day, and that is the SLA for a single EC2 instance is only 90%. So AWS themselves kind of say that, well, if you were trying to deploy a fault-tolerant application, then don't run it on one single EC2 instance. You can deploy a Tableau server cluster. In terms of achieving a sort of high availability configuration, Tableau really needs a 3-node cluster as a minimum. That is so that the failover process can work properly. If you are deploying a cluster, you probably want to make sure that you're running each of the nodes in the cluster across different availability zones. We've tested this in Tableau Hub as well, and there's no latency issues there or anything. Availability zones are just different geographically distinct locations within the same region. So they're usually a handful of data centers make up an availability zone, and there's 3 availability zones within the same city that makes up the region. In order to achieve some more proper high availability, you also want to make sure that you configure redundant processes on each node. So there's various different topologies here, depending on the number of nodes within your Tableau server that you can configure. But you basically want to make sure that you get an even spread of VizQL and backgrounder processes across all of the nodes in your cluster. VizQL and backgrounder are kind of the critical components that VizQL serves up dashboards to the front end, and backgrounder does all of the jobs in the back end. So you want to make sure that those two, you have, all your nodes in your cluster have both VizQL and backgrounder configured. And that will kind of make sure you have a decent amount of availability in case one of the nodes goes down. There is also something called the gateway process. And the gateway process is a small Apache web server, and that is the process that receives all incoming requests to a Tableau server. Now, if you're running a cluster, a 3-node cluster, for example, you would want to put a load balancer, an AWS application load balancer in front of that 3-node cluster, and that will receive all the incoming requests and forward those on to a target group. Now, wherever you put a gateway process, that server can receive requests. So to enable redundancy of the gateway process, you can configure one on each of the nodes in your cluster. And lastly, something to consider for getting a really highly available deployment on AWS is to take advantage of this Tableau Server Management add-on. And I'm actually going to talk about that in a bit more detail on the next slide. So this may not be for everybody, but the Tableau Server Management add-on is a worthwhile consideration if you're running your Tableau server in AWS, because there are a number of features and tools that you get with it that are AWS specific. If you haven't heard of the Server Management add-on, it's a suite of 6 tools and features that provide additional capabilities for Tableau Server. Some of those tools revolve around content management, resource monitoring. So you get a handy resource monitoring application, which you deploy on a separate server and point it at your Tableau server cluster, and it collects metrics and performance metrics and allows you to configure alerts and thresholds. So it kind of does the same job that you might expect of CloudWatch, but it's all set up automatically for you. You also get some additional features around background or workload management, so you can choose which nodes to run different type of background or workloads, like extract refreshes or subscriptions or Tableau prep flows. But the 3 that I wanted to talk about mainly are the external repository. So as part of this add-on, you get the ability to externalize the Tableau server repository on Amazon RDS, Relational Database Service. So you can take that Postgres database off of the server machine or machines if you're running a cluster and put that into RDS, which is a managed service, which you can configure for high availability as well. The next feature that's worth considering is the external file store, which allows you to store extracts and workbook revisions on a SAM. So in the case of AWS, you would mount an Elastic file system on all the Linux nodes in your cluster. Or if you are running a Windows cluster, you can use, I believe it's called EFX. And that is a centralized location for all of the extracts on your cluster. This gives you several benefits. The main one actually I found is that your backup size reduces massively because you no longer have to worry about including the extracts in your backups. Instead, you can just snapshot the Elastic file system disk instead, which will give you a nice static backup of that extracts NAS drive essentially. But it's also having having it all centralized on an external disk would allow you to reduce the size of your GP2 disks as well if you are using Tableau server with lots of extracts, lots of large extracts. The third feature I wanted to talk about here, which is specific to AWS as well, is the ability to store the encryption at rest master key within AWS Key Management Service. So this just is a feature where rather than having that master key on the same machine where your extracts are stored and encrypted, you can take it away, off of the machine, put it into an AWS managed service, and that just provides you a little bit more security of the cluster and security of your data, really. There is an additional cost for the add-on. I guess that's why it's called an add-on. It's $3 per user per month. So again, have a think about whether this is an investment that's worthwhile for your deployment. It may well be if you are deploying on AWS and you want those additional features. So I've actually moved this slide towards the end to emphasize its importance. But what I wanted to say is, all of the stuff that I've talked about until now, you don't really want to go and configure on your own by hand. You want to script it all. So, I highly recommend using Cloudformation or Terraform or any other kind of infrastructure as code tool to script your environment. It's a hugely important part of achieving that business continuity piece that we talked about at the beginning. Tableau and AWS have actually partnered to create a bunch of starter templates which you can use to deploy a very simple environment in AWS, and we'll link to that in a second. But basically, yeah, you want to go ahead and create templates for the infrastructure around your Tableau server. So define how, what the network should look like. You want to go on from there and create a template to deploy your server. You can create lots of different templates and nest them inside each other. And you can also create different deployment templates for your initial deployment, as well as for upgrades, which you might want to do later. And I really like this approach is once you've built that template once, if you do have a disaster and you need to recover, you just run that template again and it builds the environment automatically. With Cloudformation specifically, this is a pretty handy feature. Every Cloudformation template you run needs to be stored in an S3 bucket first. But we tend to use GitHub here to manage version control. AWS Code Pipeline actually has a handy facility to sync between GitHub repo and an S3 bucket. And I've linked to an article there which shows you how to do it. And here's a link to the AWS Quick Starts. So have a look at this. It's got a very handy deployment guide on deploying a Tableau server to the AWS cloud. It also links you through to a GitHub repo where you can download some starter templates, which will stand up a very basic Tableau server. But I would grab a hold of those templates and customize them for your own environment. Okay, and finally, I just wanted to close on strategy and planning. I left this slide for last as well, because if there's one thing I want you to remember from this talk, it's this, and that's to just generally talk about and plan and discuss and agree on your deployment approach beforehand, before you do any of this. Some things to think about here, decide how critical your Tableau service is to your organization. And when we talk about that, we talk about what's your recovery time objective, how quickly do you need to get your server back up and running after an event, a failure event, and what's your recovery point objective? How much data loss can we afford? Do we need to make sure that we've saved everything right up until the second that there was a failover event? Now, every business is different. Every organization is going to have different requirements around this, so it's worth talking about what's acceptable here in your business. And in IT, you might have some processes or policies that define this for you automatically. Definitely take some time to agree and document your availability metrics and your targets. So we talked a lot about monitoring and alerting. You want to make sure that you agree on what thresholds, what alerts you should set and define those properly beforehand. And definitely take some time to document your availability, your backup, and your recovery strategies. Those are three separate things. So having that all written down, defining what you want to do in each of those cases will help you design the system going forward. And then assign appropriate resources for DevOps. So, we talked about scripting your infrastructure as code. That takes time and skills as well. Cloudformation is quite easy to learn. It's basically JSON or YAML templates which define your infrastructure. but there is a bit of time that you need to invest in upfront to get those templates just right for your environment. I would definitely follow that kind of software development lifecycle for Tableau Server, in that you should use these templates to stand up a dev server, then perhaps stand up a testing server, and then production. The content on the server, however, that's a different story. I wouldn't necessarily follow that SDLC process with content on the server, but certainly follow it for deploying the server platform itself. It will take time, but it's definitely worth it in the end, especially from a business continuity perspective. Okie dokie. That is everything. Thanks very much for your time. I'm going to have a look at the questions in the chat now and do my best to answer them. Let's see what we've got here. Okay. If anybody has any questions as well, feel free to pop them into the chat. There was a question around whether the session will be recorded. Yes, it is being recorded. It will be on our YouTube channel a day or two from now when we get a chance to pop it up there. There was this is more of a comment from James as opposed to a question, but it's just around setting the correct ciphers on the application load balancer. And it's a good point, James. When you deploy AWS load balancer, you can define what security protocols and security ciphers that load balancer will accept. There's a drop down where you can choose from a bunch of different options. You want to have a look in the AWS documentation there and make sure you pick a fairly strict security policy, SSL policy on there. And what that does is it limits accepted protocols to things like TLS 1.2 and so on. A question from Steve as well. The external file store is a content store. I believe you mean file store, Steve. Is that only available with the server management add-on? Correct, yes. It is a feature that only comes with the server management add-on. Okay, I think that's it. Thank you very much for your time, everyone. Feel free to reach out to me if you've got any follow-up questions or if you wanted to talk about anything else in the presentation. My email is jmac@theinformationlab.co.uk. You can also reach out to me on Twitter. My Twitter handle's on the slide there. I appreciate your time today. Thanks.